So today's video is going to be about buttoning up some loose ends on the Datsun. So I know I'm all over the place. It's K-Trucks one day, and then GTRs the next, and then I'm working on the Buicks the day after that. But with as many cars as I have, it's kind of hard to ever find time to just sit and work on one project from start to finish. I just have to work on little projects here and there, and then sometimes they sit for a while I'm waiting on either the motivation or parts or just decision making. So these Z projects, they're just kind of all over the place. These are mostly just little touches I've been working on, and some of them have actually been done for years now, but I'm just now putting them together into one video. So I'm calling this video, Let's Get Shit Done Already, Datsun Edition. Now most of these projects are specific to the Datsun, but they have some crossover in other applications, whether you have a K car or anything else. I'm going to be doing 3D printing, welding, grinding, nickel plating, upholstery, everything all in one video, and a little bit of fabrication to boot, as well as showing you how I'm going to do some wire management, and who knows what else by the time we're done with this video. So let's get started. So we're going to reupholster the steering wheel. I bought one of the wheel skins wheel covers. It's not in the worst shape, but it could be better. A little rough. So I've already pulled the fuse, so now my horn doesn't actually do anything. And the way that you take the horn pad off is you push in, turn to the left counterclockwise, and then the horn button pops off, and then there's a spring in there. That's what keeps the horn from going off all the time. This is a 5/16, but it's a little loose. I've had this horn off a few times, so this nut is not super tight. And then a little lock washer. And then I'm gonna put the phone down so I can give the steering wheel a little wiggle. Sometimes you might need a steering wheel puller to do this, but again, I've had mine off recently, so it's not too bad. And there, that's off. Then we'll just put the washer and nut back on for safety. And then let's go inside and get this upholstered. Putting this wheel cover on is actually pretty easy, and this is the first time I've ever done it. This wheel skins cover is a perfect fit for a stock 280Z wheel, so it should be the right thickness to go over the old rubber stuff that's starting to fail. First, you start with a stitch like this. And then once these 3 stitches are in place, you pull them tight and continue along. You basically go from hole to hole, tightening along the way and keeping the stitches straight as you go. I used a little Velcro holder to hold the leather tight as I went along. It helped out a lot to keep all the stitches in a straight line. You kind of skip the back stitches as you go around the spokes, and you just go through the front holes. It would have been nice to have one that covered these little parts that stick into the spoke, but maybe one day I'll cut a custom piece of leather and do that myself. Other than that, the trickiest part is when you get to the end, you have to make a little knot around the final stitch so it doesn't become frayed. Then that's it. It's pretty tight. It doesn't slide around or anything. But there are a few small wrinkles in it, and I suppose I could have gotten those out if I had lined it first. But as it is right now, the wheel is a little thicker in my hand and it has a really nice feeling to it. That was pretty quick and easy, so we'll reinstall the wheel now. After I reassemble everything, I check my wheel is straight and then reinsert the horn spring and the horn pad. I'm back in business. Get the fuse put it back in for the horn, and then we'll be good to go. Today we're going to be repairing the inspection light on my 280Z. The inspection light is a little light that sits in the engine bay. What you can do is unpop it from its base, and it will unravel on this big long cord. And then this way, if you have something wrong in your motor and it's nighttime and you need to see what you're doing, you turn the switch on and it lights up. You kind of look around your engine and see what's going on. It's a pretty fancy little piece. This one's seen better days. The plastic housing is melted or broken, and then the bulb isn't in it right now, but it wasn't working when I tested it with the bulb. So what I tracked it down to is this little switch down here isn't working. So what we're going to do is get this housing out, get it all cleaned up and polished up, and then we'll be replacing that wiring switch and see if we can't get this to work. By the way, I could have just bought one of these reconditioned for about 175 bucks. So let's keep a running total of how much this housing cost me to rebuild. So I don't lose the bolts, I'm putting them right back where they were. That'll also hold the heat shield on, so I can drive the car around without any worry about the heat shield falling off. So here's the inspection light. It appears to be pretty simple. I'm just going to remove this switch and then resolder and rewire in some new electronics into it. I might replace the wiring inside of this, but I think it's actually okay, so I'll probably just leave it alone. But I do have to replace this plastic tip. It's gotten all melted and cracked over the years. It's a 42-year-old car, so you know, needs a little bit of love here and there. So first what we're going to do is polish this up and get it all repaired and looking nice, and then we'll start working on the electronics. As you can see in there, the wiring is relatively simple, so we will just get that switch out of there and see what the wires look like. So to get the wiring out of this housing, we're going to have to release this solder point here. The negative side of the light is just soldered right to the housing on the actual fixture. So we're just going to put a little heat there. And that'll be free. I'll have to replace this grommet. It's falling apart. There's a little tab in there that's holding this wire still, so I'm going to have to get something in there to pry that out. What's in there is two little prongs that hold on to that wire that are wrapped in red. I'm trying not to do this without ruining the wires, but in the worst case we'll just replace those. Okay, that should be free now. And out comes all of the wiring. So here is the old switch. Like I said, I tested this to make sure that it wasn't working. So what we're going to do is replace this with a pretty much identical switch and then get it all put back into the housing. Now that we have all the parts removed from the housing, I'm going to clean it up really good and then probably reapply the nickel finish to it. So I actually found a CAD file online to 3D print this little inspection light dome. So we're going to go ahead and do that out of some translucent plastic. I found a switch to replace the bad switch. This one will handle 30 amps at 12 volts, so it'll be more than overkill for the actual light. It's a little larger, but it should still fit inside the housing, and it's wired a little differently than the other light was wired. It'll basically sit in there something like that. I'm going to unsolder these wires from the old switch so I can reuse them. I put a small LED in the housing and touch it to a 12-volt source to make sure that the wires are okay and they don't have any breaks in them. However, after seeing how dull the light is, I kind of want to switch to a different type of LED chip, something much brighter. So these parts originally had a zinc coating on them, but I don't have any zinc, so we're going to do nickel instead. But first I'm going to clean up all the crud on this housing. Then it's into the nickel bath for plating. Basically, you apply a negative current to the part and a positive through the sacrificial nickel anode. You paste that all in a bath of Epsom salts, and this creates a flow of nickel particles to coat the part. There's a lot of sciencey info on the current and the voltage, but sorry, I don't remember all of why I chose these settings. You may have to look elsewhere on YouTube for that information. Here's the part fresh out of the bath, and it has a flat appearance. So we're going to polish it up now. But before I do that, I'm going to wire up this new LED chip. I scavenged this out of a 12-volt flashlight that I had laying around, and it became a sacrifice to the almighty Z. I solder it up and make sure that the current flows in the correct direction. This is important with LED chips. Then I just kind of slide it down to where the old light housing is, and I pull it snug. With some heat shrink, it should sit tight right here. This original insulator is all melted and crappy, so I'm going to make a new one out of a very large grommet. I cut the grommet in half to be a little bit thinner, and then after a little adjustment, it's ready to go. Now we go ahead and use Mother's chrome polish to put a nice shine on the housing. I did hit it with my polishing wheel first, and then I used the Mother's polish to finish up the shine. I then do the same for the removable end with the light in it. And here's everything all polished up. It's not a perfect mirror, but it's pretty shiny. Now let's get the switch all wired up. First, I strip back the old wire to create new ends. I decided to go with a different switch. This one is arranged just like the OEM one with a single pole throw. I didn't realize that the first one I was showing was a 2-position switch, so we're going to use this one instead. I test fit this one inside the housing, and then I use some spade connectors on everything, so this way it's an easy swap if I ever have to change this switch in the future. First, I solder up the ground connections. I decided to attach the ground point inside the housing instead of outside. I can't remember why I did that, but I had a good reason. I then crimp and solder all of the connections and use heat shrink on everything that I can. I then put a new grommet in the back of the housing to pull the power lead out of, but I have to sand it down a bit to get the new one to fit. And then I wrap up all the wiring. Let's 3D print the plastic dome for the light. I'm pretty sure I found this file on Thingiverse. I just downloaded it and then loaded up some translucent filament in my printer and let it go to town. This was actually one of the first things I've ever printed. It was actually super easy, and I think it came out pretty great. I check the fitment of it in the housing, and then I bench test it one more time. I do a little more sanding onto that rubber gasket, and then it's into the Z. The next thing we're going to do in this video is shave the valve cover on the engine. On these L-series engines, there's a set of screws that hold the standoffs that route the spark plug wires over the top of the engine. I don't like this look, so I had already made a custom set of wires in another video where I route the wires around the front of the engine for a much cleaner look. The consequence of that is that these little standoffs are no longer needed, and they disrupt the look of an otherwise pretty clean engine bay. So let's get rid of those. So I picked up a spare valve cover to do this, so this way I could take my time and not run the risk of ruining the original one. First, I'm going to grind these down. You have to be careful not to gouge or cut into the aluminum surface while you're doing this. Then, with my TIG welder and some aluminum filler rod, I weld up the remaining holes to create a cleaner look. I then get it painted with some high heat bronze paint. Here it is compared to the wheels. It's a little bit more gold than brown, but I think the color is pretty close. If I do figure out the actual bronze color on the rim, I'll spend the extra money and have this one powder coated. So let's get this installed. So here are the two valve covers side by side. This one has had all of the bosses shaved off. I'm going to reuse my old gasket since it's only been on for about a year or so and it's in relatively good shape. That was almost borderline horrible. I dropped the screw from this little vent into the head. That would have been a problem. So don't do that. All right, let's put this back together. I tighten up the valve cover using the cross pattern by jumping to either side and working my way in. I believe the factory service manual says start on the inside and work your way out, but I don't believe it's as integral since this is just a cover to keep the oil in and the dirt out. But if I do get a leak, that's probably why. And here is the final result on the valve cover. Now I have one more project to do in the engine bay that I'm working on. I'm not sure how far we're going to get in this video with it, but I want to clean up this engine bay even more. This mess of fuel injection, it drives me nuts. Basically, there are two ways to fix this. The first option is the nuclear route. We get a new intake manifold and a computer and clean up all this old 70s tech. I do eventually want to do this, but it's not in the budget right now. So the next best option for me is a new fuel regulator and fuel rail. This is going to simplify about 75% of what's here and actually leave us with a pretty similar look. So a little spoiler alert, I didn't actually finish the installation of this as of the release of this video. I will show the finished product in a future video. I'm just waiting for a couple things to come in and waiting to complete some other projects. In the meantime, it'll show you all the pieces that we need to get the fuel rail installed. So this is all the old components of the fuel rail. Here is the new stuff. This is what I got in the kit from Pro Tuners. This rail, these fittings, and the mounting brackets. I purchased a fuel pressure regulator to go in there, and I purchased new injectors. The new injectors also came with some pigtails for the ejector wires, and I picked up a set of harnesses to create new pigtails. Because what I might do rather than using the pigtails is just run these wires the direction where they need to go as far as they need to go. Ideally, what I'd like to do is run the wiring for the injectors up the edge of the fuel rail and then back and over to where it connects to the car on the harness. Let's look at why we're going to do this. This is going to replace a lot of these extra hoses and lines that run around. This will probably do zero performance-wise. All this is going to do is just clean up this overall area of the engine bay. There's so many wires and hoses and everything that run around here, and they all serve a purpose. And the more you change them, the more likely that the car will not run properly. But I hate how this looks. I really want to clean it up a bunch. It's so complicated, everything that's going on in here. So there's a few things that I'm going to do in the future with this. One of them is that I'm probably going to add a computer system to the car that is not from 1977. They make much better computer systems now. The Mega Squirt, the Fasties, EFI, Godzilla Raceworks makes one. There's a bunch of different manufacturers that make essentially a computer system that will control the engine with more flexibility. Most of those are better if you have a turbo setup or if you have bigger fuel injectors, and we're not doing any of that yet. So that's why I'm not worried about doing the computer system. Plus, this car runs great right now, so I don't really want to mess with something that's not broken. In fact, I'm already kind of worried about changing this fuel rail for that same reason. Because it runs so good right now, I'm worried that I'm going to screw it up. But we're going to give it a shot and see what happens. I have all new injectors for it, so this way I can build the rail as one piece and then just install it into the car in one go, and not take the car off the road. So I've had this fuel rail off before. It's relatively easy. There's a bolt here and a bolt here, and you take the whole fuel rail off. We have to make some disconnects over here by the canister and the fuel filter. And then the other thing I'd like to do, this big harness right here holds all of the injector wires. They just pop in to all of these spots here. So in order to help clean up this area some, I'd really like to run all the wires this way, up the firewall, and then back over, and then to hook up to this body harness. The intake manifold itself is pretty messy. There's a lot of stuff going on it. ProTuners also makes a replacement intake manifold, but that would definitely require that I install a computer, because at that point you switch to a mass airflow and you make a bunch of other changes to the car. So we're not going to get there yet. I do have to make a slight adjustment with this. This little actuator is for the air conditioning. When the air conditioning turns on, it pulls back on this valve here, which in turn pulls back on the throttle and gives a little bit more RPM. Again, this is one of those weird things that I think with the computer would solve that, and I could actually remove this, but in the meantime I need this to actually be on. Otherwise, sometimes I'll stall at a stop sign if the air conditioner's on. So what this does is when you turn the AC on, it clicks a relay over on this side of the car, and then the relay turns on a vacuum line, and then the vacuum pulls this back, and all it does is just pull. You can see that little bit of motion where it just pulls on the throttle linkage and just gives you a few more RPM. So we're gonna make a little adjustment with that. Now, one of the unique things about this car is that the 280s have a 7th fuel injector. So there's 6 cylinders, and each cylinder of course has a fuel injector, and then there's a 7th fuel injector which sits right here. And what this fuel injector does is on cold starts actually provides extra gas to the whole system. Right now I'm not sure if I'm going to keep that or not. I'm in Florida. This car's probably always going to be in Florida, with the exception of it being in a colder climate. There's really, from what I hear, there's really not a lot of reason to have that extra 7th injector. But this ProTuners billet rail does have a port out the bottom, which I can probably bring over to put onto the 7th injector. So I'm probably going to keep it in place for now. But again, knowing that once I do the computer changeover, I'll probably be able to eliminate that from the system. There's also, again, a lot of other hoses from the PCV valve and then over into these other intake hoses. I'm not 100% sure what all of those do. I've seen a lot of people remove them all, and then I've seen a lot of people leave them and explain that as you remove that stuff, you're just introducing new problems into the car. So I don't know. We're going to decide whether or not we're going to remove them or not. But at that point in time, we'll figure out if we want to do that. For right now, we're just going to work on the fuel rail, and we're going to leave everything else in place. And then this way, if I eliminate one element at a time, I can determine whether or not that's actually causing problems. But first off, let's go inside and take this fuel rail, and we're going to start building all the pieces on the fuel rail ready to install. I begin by trimming the hoses from the injectors to be an exact height for the fuel rail, and then install the fittings. I use a fuel-safe pipe sealant on all the fittings. Okay, so basically this is what we came up with in putting together the fuel rail. Let's talk a little bit about this old fuel rail. So the intake into the fuel system comes from here. So the fuel pump basically pushes fuel to that zinc-plated fuel filter right there. Travels up this line into the fuel rail right here. It comes to this little union spot and then throws fuel through the whole system here. I'm sure there was a point to this back in '77, but there's not much of a point to this now. We can maintain good enough pressure. There is a fuel pressure regulator right here. We're going to be removing this pressure regulator and mounting it onto the side of the fender well somewhere near the fuel pump. What will happen is this rail will take up most of the metal bits right there, and it'll just be the one smooth rail. I mounted the barbed fittings on here, and I used a little bit of thread sealer with it, or pipe sealer. I'm sure there's a lot of argument as to whether or not that's necessary or if that's going to cause problems, but everything I read basically said that's a good way to do it, and it is fuel safe. I also installed a 7th line here for the 7th fuel injector. In the interest of keeping this car as factory as possible until I get a new computer into it, I'm going to maintain that 7th injector. I just don't want to find any unforeseen issues later on after I pull that off. But we'll test it on and off and see what happens, and if it is useful off, I can pull this little return line, put a little blocker in there, and then I can actually just delete all of the 7th injector stuff. So the way I decided to do this was to use the kit I have to wire up a full set of wires for new fuel injectors. I start by measuring the most wire I'll need to get from the furthest injector to the firewall and then back to the harness. I then split the wire and strip back the coating. I have to slide on these small waterproof Reddit insulators first to each side of the wire. Then I crimp on the injector's positive and negative fittings. I want these to be positioned so they're not twisted or binded once they go into the plastic housing. I quickly check to see which side is positive and which side is negative to make sure to install the wires in the housing appropriately. I'm going to install the red to the positive side, so now we then clip the fittings into the housing. I use a screwdriver to push the waterproof fitting into the housing and then the back part of the clip. I clip it into the injector to test fit it, and there we are, ready to install. 1 down, 5 more to go. Next, I'm going to scooch all the injectors onto the barbed fittings and screw them down. There's the rail with the injectors installed. Now, let's make it pretty. I'm going to use some wire ties to organize and separate the wires. Now let's make it really pretty. I use Croxy split wire looms to cover each of the individual wires. I use heat shrink on each injector to give it rigidity and close the wire loom. So I really enjoy taking all of this wiring and making it look really nice and organized in the car. I feel like putting this loom on it just kind of adds a streamlined look to all this wiring. And again, this is really going to clean up a lot of this excess wire on the top of the intake manifold. I then organize and route them all down the rail, and then use one big sleeve to hold them all together. And there's a fuel injector rail ready to be installed. I decided to install a new style fuel filter with AN fittings, since the rail has AN fittings also, and so does the regulator. So next, let's make up a new bracket that's going to hold that in place right where the old one was. First, I cut a couple templates out of cardboard. This triangular shape is going to replicate the stock fuel filter bracket where it attaches to the inner fender. Then this flat part will allow us to adapt it to the new fuel filter and bracket system. I could use the new fuel filter bracket and just mount it to the fender, but that would require putting extra holes in a pretty clean and factory condition fender. So next, let's get these shapes cut out of metal and get them welded together. This scrap piece of metal I have looks like it'll be the perfect size for this bracket, so let's mark out the shapes. I use the new fuel filter bracket to mark out the length so I know it should be good when I'm ready to mount it. I use a grinder and a cutoff wheel to cut the basic shapes out. I smooth it all out with a flap wheel and the belt sander. I go ahead and mark out the 3 center holes for the side that's going to mount to the inner fender, and the 2 holes for the fuel filter bracket. I go ahead and drill some pilot holes, then use the stepper bit to clean them up. Next, I'm going to weld up the bracket. I use one of those little magnets to hold everything at a 90, and then get some tacks welded in before the final weld. I do a quick little cleanup with the wire wheel, and not too bad. Ignore this little scar on the back of it, it got caught in my belt sander while I was cleaning up the backside. That's going to be hidden up against the inner fender anyway. So now let's take a look at where it's going to sit in the car. Of course I pulled the car out for like 2 minutes and it starts to rain. Okay, so this is going to replace this bracket right here. It's going to mount on the inner fender, and then we're going to remove this old fuel filter and swap it over to the one with the AN fittings. Okay, so I actually ran out of time and I wasn't able to get this installed yet, so we're going to do that in an upcoming video, and we'll see how awesome it looks once it's installed in the car. But we did make a bunch of progress on all this little stuff on the Z. I believe in the next video we're going to be bringing back the Beast. That's right, Slave 1 is going to be back as I show you the progress that I've been making on the repairs to it. And as always, thanks again for watching. Whatever you do, do not like this video, it only encourages me to keep going. And only subscribe if you really want me to stop doing this. I think I'm just going to retire at 100,000 subscribers. See you next time.